Okay, so real briefly here, I want to discuss with you what's called the first derivative test. All right, the first derivative test. And what we're trying to do is we're trying to analyze a function. We may or may not actually have a picture of the function, all right, but we are able to tell some things about the function just by looking at the derivative, okay? Now, you'll see here I have a couple different functions drawn, and I also have some different tangent lines drawn on these functions, okay? So I have this point of tangency and this tangent line drawn, okay? Here we have a point of tangency and a tangent line drawn, another point of tangency and a tangent line drawn, okay? And then you have over here the same thing, a couple others. You have this one, though, that's kind of odd, because it actually goes through the whole thing. And then here you have a point of tangency with the tangent line drawn as well. But here is our first derivative test. Okay, and there are three parts to this. If f prime of c is positive, then f is increasing in a neighborhood of the point c f of c. Okay, when we say in a neighborhood of the point, we're saying that that point is in an interval that is increasing. Okay, and we'll talk about how to define those intervals here. If f prime of c is negative, then f is decreasing in a neighborhood of the point c f of c. And then finally, f prime of c is 0, then the point may be one of three things: a relative maximum, a relative minimum, or a plateau point. Okay? Now, we use the term relative here as opposed to absolute because, for example, on this parabola here, this continues to go forever, so there is no absolute minimum. It keeps going to negative infinity. All right? However, if we were to cut this off on a particular interval, we could identify a local or a relative minimum. In this case, this point here, you guys know is the vertex. That would be a relative maximum and an absolute maximum, because we know the function doesn't go up any higher than this. Where the relative kind of comes in handy is things like maybe a cubic function like this. This point right here would be a relative maximum point. And this point right here would be a relative minimum point. Now we know, because this continues to go forever in the negative direction, that it's not the minimum of the function, but it's a relative min. It's a point where the function dips down, it doesn't go any further before it starts going back up. Okay? Likewise on the maximum, there is part of the function that goes higher than that, but in that smaller interval, it is the highest point. Okay? So that is something that can be useful here. And really, this f prime of c equaling 0 is going to be something we're going to do a whole lot of. Okay? In fact, when we were just looking at rectilinear motion, we saw when the velocity changed and the movement, when the velocity was 0, we were changing from moving to the right to moving to the left. That's the same thing as a difference of changing from increasing to decreasing. Okay? Now, let me show you the sign diagram for these, just so that you can see it and relate it to what we're talking about here. Okay? So, you'll notice here this maximum point on the parabola to the left is at 2. So if I were making a sign diagram just for f prime, which if this were a displacement function, then that would be our derivative, that would be our velocity. But you could do the same thing with these as well, okay? So you have x, and you have this value of 2, okay? Now, at 2, the derivative is 0, okay? We have a horizontal tangent line. What is the slope of the line to the left of 2?
Positive.
It's positive. And to the right of 2, the slope of the tangent line is?
Negative.
Negative. Okay? Now, with that being said, now we can actually look at what's happening to f of x. Okay?
That's super. You're welcome.
Let me move this up above, actually. So here's f of x. All right? So, when the derivative is positive, our function is increasing. When it is negative, it is decreasing. And what do you get between a section that's increasing and a section that's decreasing?
Maximum.
Zero.
You get where it's 0, which gives us a relative maximum. Okay? That's going to be a relative maximum because we were increasing, now we're changing to decreasing. So at some point we had to get to that highest point. All right? So that right there is our relative maximum, or we could just say max for short.
What if you have multiple max?
You can. That is possible. Okay?
So Mr. Hickson, the reason that you got that f prime of x at x is 2, you got that to be 0 because there's a horizontal asymptote at the tangent.
Yes.
Gotcha.
Yes. Okay. Now, we could do the same thing over here on this side at where x equals 2 is where f prime of x equals 0. Okay? But we also can see that to the left of that, what's the slope of our tangent line? It's positive. It's going up, right? It's positive. So our function is doing what at this point?
Increasing.
Increasing. Oh, which we can just draw the arrow if we like.
Who like that?
Okay? It's increasing. To the right of that 2, what's our function, or what is our derivative?
Positive.
It's still positive. It still has a positive slope.
So you could say that f of x is increasing.
So f of x is increasing over there as well. So what do we get when it's increasing, levels off for just a moment, but then continues to increase? That's a plateau. That's a plateau point. Okay?
I can't write that on my iPad. Some skills, Mr. Hickson.
Plateau point.
What is plateau mean?
A plateau is a word, it's actually a geographical term. A plateau is a place where, you've got land and there's just a flat piece of land like that.
Oh, I thought it was
Okay.
a smooth.
Thank you.
So it's a leveled off
Period.
part of land.
Okay.
Does it have to be like straight on top or can it be a hill?
And it doesn't have to be perfectly flat on top, but typically a plateau, to distinguish it from a hill or a mountain, a plateau is something that's kind of raised and it is pretty flat on the top of it. Okay? Well, that's why it's called a plateau point, because we're going up to it or down to it, it levels off and then continues to go down.
Oh, so
Okay.
both are plateaus, not only the right one?
No, the plateau is a point. The
Oh.
point to whatever that is on the graph, this right here is the plateau point.
Why is this the plateau point and not one on the left or the slight right?
Because that just happens to be the moment when the derivative equals 0 exactly.
Oh, okay.
The other, to the left and the right, it's really, really close to 0, but at that moment it equals 0, so that's the plateau point. And I know it's maybe a little bit deceptive looking at the picture because it looks like it's perfectly flat for a while there. It's not. It's only flat for that one moment in time.
Yeah.
Okay? But this is our first derivative test. We'll use this quite a bit to look at a function and be able to tell what's going on. Okay? You can also use this with the rectilinear motion ones. Instead of increasing and decreasing, we simply have moving to the right and moving to the left. Okay? That's really the only difference. Alright? So our sign diagram, or down here it says number line graphs for f prime. That's like what we did above there. If you don't like putting the actual boxes, another way that you could write that, I'll just show you here with this one, and this tends to make sense with some people a little bit more. They'll just put a line here, they'll mark 2 like this, okay? And then up here, they'll actually just put f of x and f prime of x. And we know that this is 0. It's positive here, positive here. The function is increasing here and increasing here. That's another way of drawing that. That may be a little bit simpler than making the actual tables. Honestly, I draw mine that way more often anyways, so.
Below the line, is it a 0? Or 2?
Yeah, that's a 0. This is just where x equals 2 and the derivative equals 0. Okay? So, let's take a few minutes here and try these and see how you do. Okay, for the solution of these, we'll notice we have tangent lines that are horizontal at 2 in each case. So, for the number line graph, if you look down here at the bottom, you can see an example of a number line graph, similar to the ones that we wrote up above. But if we have f prime of x, and draw a line here, and we'll put 2 right here, okay? Because that is where f prime of x equals 0. Alright? Now, you'll notice to the left, our tangent lines are going to be going up like this, so that means our derivative is positive, and that means the function itself is going to be increasing. Okay? I like to draw a little arrow like that to indicate it's increasing, even though that's not a value of x. And then to the right, you'll notice our tangent lines are now going downward. That means our slope is negative, so the derivative's negative, and our whole function is decreasing. All right, so there's our first derivative test here. And by the way, notice here, because it's increasing on the left and decreasing on the right, that means at 2 we have a relative max. Relative max at x equals 2. Okay, which is obvious if you look at it. Then over here, another one we've got our f prime of x. We're going to put 2 on here, but notice to the left of that, our tangent lines have a negative slope, so that means our derivative is negative. And 2 should be down below. So that's the value of x. The derivative is 0 at that point because the tangent's horizontal. But now we start to increase on the right-hand side. Our derivative is positive. All right, and we can see here the function is decreasing. Then it levels off at 2, and then it's increasing. And that shows us that we have a relative minimum point at x equals 2. Okay? And then finally, the third one here, you can see, again, f prime of x is 0 at 2. To the left, our tangent lines have a positive slope, so the derivative is positive. To the right, our tangent lines also have a positive slope, so the derivative is positive. That means we're increasing, then it levels off at 2, and then it continues to increase here. And anytime you have no change in direction, they continue to increase or continue to decrease, you have a plateau point, in this case at x equals 2. Okay? Next, down here, interpreting these is important here. So notice where the zeros are. Okay, the zeros, remember those are max or min points or plateau points. Here we have a positive derivative, which means we're increasing. Then between these two zeros of our derivative, it is negative, so the function, let's say f of x, is going to be decreasing. Then between these two zeros, the derivative turns positive again, so we're increasing. And then after the last 0, it is decreasing. And notice here, as you're drawing these lines, we're asked to sketch the graph of a continuous function that's continuous, or that's consistent with this information. Basically, if you follow the arrows that you have, you can do this. Up, then down, up, and then down. And that highest point is going to be at -2. Should have moved my y-axis over a little bit. Wasn't paying attention to that. So let's say that this is -2. And then here at 1, notice we're changing from decreasing to increasing, so that's going to be a relative min point. And then here at 3, it changes from increasing to decreasing. So we have a relative max, okay? So, just to sum this up, we have relative max points at x equals -2 and 3. It's possible to have more than one relative max. We're not talking about an absolute max. We also have relative min point at x equals 1. Okay? Over here, same idea. Derivative's negative, so we're decreasing. Here the derivative's positive, we're increasing. Here the derivative is positive, so we're increasing still. And then over here the derivative is negative. So, I'll pay attention to where I'm at on the x-axis again. So we're at -1 to -3. And then this occurs over at 1, 2, 3. Alright, so we have, you could see here, a relative min at -3. So let's say it's down here. And then you'll notice, so it was decreasing until we got there. Then it started to increase. Then the tangent went horizontal. So let's say it's there. Okay? So there we have the plateau point, okay? That's a plateau because it was increasing and then continues to increase afterwards, and then reaches a max point once we get to x equals 3 and starts going downhill from there. Okay? So we have a max at x equals 3, we had a min at x equals -3, and a plateau at -1. Okay, and your graphs may look a little bit different, but those are the key things. You've got to have the max and min points at those x values and have the graphs going up or down, increasing or decreasing the way we've got it here. Okay, there we go.